Picture this, the universe we call home, with its countless stars, galaxies and fundamental laws, is just one small bubble in a vast, infinite ocean. Now imagine that ocean teeming with other bubbles, each one a separate universe, some eerily similar to ours, others unimaginably alien. Could this be the ultimate truth about reality? And if it is, what does it mean for us? Buckle up as we embark on a journey to uncover the secrets of bubble universes and challenge everything we think we know. The idea of multiple universes, or the multiverse, isn't just a product of science fiction. It's deeply rooted in modern cosmology. It all begins with the Big Bang, the moment of creation that brought our universe into existence around 13.8 billion years ago. This singular event set the stage for everything we know, but the deeper scientists have looked into the origins of the Big Bang, the more questions they've uncovered. One of the most revolutionary breakthroughs came in the 1980s with the theory of cosmic inflation. Proposed by physicist Alan Guth, this theory suggests that in the fraction of a second following the Big Bang, the universe expanded at an unimaginable rate, growing exponentially faster than the speed of light. But inflation wasn't uniform. Quantum mechanics, the science of the very small, tells us that tiny fluctuations during this period cause certain regions of space to behave differently. Here's where things get interesting. Some regions stopped inflating, giving rise to galaxies, stars and planets. But other regions kept inflating, creating vast bubbles of space-time. Each of these bubbles could become its own universe, completely separate from ours. This process, called eternal inflation, suggests that the creation of new universes is a never-ending process. Our universe is just one bubble in a vast multiverse, each bubble with its own unique properties and physical laws. Imagine the implications of this. In one bubble, gravity might be so strong that stars collapse before they can form. In another, the speed of light might be faster, or entirely new elements might exist. The possibilities are endless. This concept doesn't just redefine our understanding of the universe, it reshapes the very definition of reality itself. The observable universe is a staggering 93 billion light-years across, but this is only what we can see. The question of what lies beyond its edge has fascinated scientists and philosophers for centuries. In the context of the multiverse theory, the answer might be more mind-bending than we ever imagined. According to eternal inflation, beyond the visible horizon of our universe lies a vast expanse of inflating space. This inflating region, sometimes called the false vacuum, is like an ever-expanding sea, continuously spawning new bubbles. Each bubble represents a universe with its own unique properties. But what separates these universes? The answer lies in the fabric of space-time itself. The false vacuum acts as a kind of barrier, isolating each universe, yet some physicists theorize that these barriers might not be absolute. Under certain conditions, universes could interact or even collide. Imagine two bubbles in a pot of boiling water merging into one. Such a collision could have catastrophic consequences, fundamentally altering the structure of both universes. What's even more intriguing is that evidence of these collisions might be detectable. Scientists have speculated that anomalies in the cosmic microwave background radiation, the faint afterglow of the Big Bang, could be signs of other universes interacting with ours. These bruises on the fabric of space-time are tantalizing hints of a reality far beyond our comprehension. So what lies beyond our universe? Perhaps infinite possibilities, each as mysterious and awe-inspiring as the next. The multiverse challenges us to think beyond the confines of what we can observe, opening the door to a cosmic landscape that is as humbling as it is beautiful. Eternal inflation is the heart of the multiverse theory, but what exactly makes it tick? To understand this, we must delve into the heart of cosmic physics. It begins with the idea of the false vacuum, a state of space-time filled with an immense amount of energy. Think of it as a balloon that's constantly expanding, but at an ever-increasing rate. In the very early stages of the universe, shortly after the Big Bang, space-time itself expanded rapidly. The rapid inflation caused a ripple in space, creating quantum fluctuations that resulted in the formation of different regions. Some of these regions inflated so much that they reached what is called eternal inflation. This state is characterized by regions of space that continue expanding indefinitely. As a result, new universes are continuously created. Eternal inflation isn't just theoretical, it's a well-supported concept in modern cosmology. By using mathematical models and observing the cosmic microwave background radiation, scientists have been able to support this idea, showing that the multiverse could be a natural outcome of inflationary theory. These models suggest that as space expands, it triggers the creation of new bubbles. universes that branch off from one another like the splitting of cells. The most remarkable aspect of this theory is that it implies our universe is just a snapshot of a much bigger reality. But if eternal inflation is true, it means that our universe's laws of physics, gravity, quantum mechanics, and the speed of light are just a set of rules that apply to us. In other bubbles, different laws might be at play, creating universes where the very fabric of reality could behave in ways that are unimaginable to us. Some researchers even propose that these alternate bubbles could be so strange that they might be undetectable from our own universe. The implications of eternal inflation are as profound as they are mind-bending. It suggests that reality as we know it may only be one of infinite variations, each governed by its own set of rules and characteristics. The idea of detecting other universes may seem like science fiction, but it's not as far-fetched as it might seem. As we've already seen, the cosmic microwave background radiation, or CMB, is a critical tool in studying the early universe. But what if, just beyond the light of our own universe, there's evidence of something more? Something from another bubble, another universe? Scientists have theorized that if a bubble universe were to collide with ours, it could leave behind a mark on the CMB. These marks could appear as irregularities, shifts, or anomalies in the radiation that we've been studying for decades. While these anomalies are difficult to detect, new advances in observational technology are making this possible. In fact, a number of physicists have proposed that the patterns within the CMB may contain subtle clues about the existence of other universes if we only know where and how to look. Moreover, there is a growing field of research involving gravitational waves. These ripples in space-time, which were first detected by LIGO in 2015, carry information about some of the most violent and energetic events in the universe. What if, in the far reaches of the multiverse, gravitational waves created by cosmic events in other universes could spill over into ours, leaving us with faint traces of these parallel realities? Another intriguing possibility lies in the quantum mechanics of multiverse bubbles. If other universes exist, they might be observable through quantum entanglement. In entanglement, particles become linked in such a way that the state of one particle directly affects another, even if they're light years apart. Could this phenomenon be a way for universes to influence each other? Some scientists have even suggested that the strange behavior of quantum particles might be a hint that we're not the only universe that exists. If quantum theory can connect us to other realms, could it also provide the key to detecting them? Although the technology to detect other universes may not exist yet, it's possible that future breakthroughs in physics will allow us to see beyond the confines of our own universe. If we can detect the footprints left by other bubbles, we might one day prove that the multiverse is not just a theory but a fundamental part of our reality. If the multiverse exists, it begs an even deeper question. Could life exist in these other universes? We tend to think of life as we know it based on the specific conditions and laws of physics in our own universe. But if there are an infinite number of universes, could some of them harbour life forms that are completely different from anything we can imagine? In our own universe, life requires a delicate balance of elements and conditions: carbon, water, a stable temperature range, and a few other essential factors. But in a bubble universe where the laws of physics might differ, life could take forms beyond our comprehension. Imagine a universe where the strong force of gravity dominates, preventing stars from forming. Could life, in some radically different way, still emerge in such a universe? Some scientists speculate that life could thrive in universes where the fundamental constants, like the strength of gravity or the speed of light, are vastly different from what we experience. For example, in a universe with weaker gravity, stars might burn out quickly, but could strange forms of life evolve in such a short-lived environment? Or what about a universe where time itself behaves differently, perhaps running slower or faster? Could time-altering conditions produce beings that experience time in ways utterly foreign to us? The idea of life in other universes pushes the limits of biology and chemistry. It challenges us to rethink what life even means. Could life forms exist based on silicon, ammonia, or even completely unknown elements? What if life in other universes is more like energy or consciousness, not bound by matter as we know it? If there are other universes, the possibilities for life are as infinite as the multiverse itself. While we may never be able to travel to these alternate realities, the concept of life beyond our own universe encourages us to look at the very definition of life in a broader, more imaginative way. It reminds us that the universe is far stranger than we could ever have imagined, and we're just beginning to scratch the surface. One of the most compelling yet baffling aspects of the multiverse theory lies in quantum mechanics. Quantum physics has always been a strange and mysterious field. Particles exist in multiple states at once, wave functions collapse upon observation, and quantum entanglement defies the very fabric of space and time. But how does this relate to the existence of other universes? The answer may lie in the principle of superposition. In quantum mechanics, particles can exist in multiple states simultaneously. This is known as a quantum superposition. For example, an electron might be in multiple positions at once, only choosing its final location when measured. Now imagine a universe governed by quantum mechanics where each decision or event creates branching possibilities, each one resulting in a different outcome, creating a new universe. In the context of the multiverse, this means that every possible outcome of every event that could have occurred does occur, except in parallel universes. As quantum particles collapse into specific states upon observation, an infinite number of possibilities unfold simultaneously in separate parallel universes. From this perspective, the multiverse could be seen as an infinite array of universes, each corresponding to a different outcome of the quantum events occurring at any given moment. Quantum mechanics also suggests the possibility of many worlds, another theoretical idea related to the multiverse. According to this theory, every time a quantum event occurs, the universe splits into different versions of reality, each with a different outcome. Think of it as opening multiple doors, each leading to a different reality. This idea challenges our understanding of time, reality, and free will, suggesting that the universe is far more complex and interconnected than we ever imagined. For example, take the infamous double-slit experiment in quantum physics. In this experiment, particles like electrons are fired through two slits and behave like waves, creating an interference pattern. However, when observed, they act as particles, not waves. This strange duality could suggest that, in an unobserved state, particles might explore multiple possible pathways, thereby creating new universes for each possibility. But could quantum mechanics be the key to unlocking the multiverse? If quantum superposition allows for the existence of multiple outcomes, then the idea of parallel universes may not be as far-fetched as we think. In fact, it could be a natural consequence of quantum mechanics itself. Quantum tunneling, another fascinating aspect of the theory, could also play a role in the creation of new universes. It's a strange phenomenon where particles move through barriers they would otherwise be unable to cross, possibly leading to the formation of new bubbles or universes. The more we dive into the mysterious world of quantum mechanics, the closer we might come to understanding the true nature of the multiverse. If the multiverse theory is correct, how could other universes affect our own? The possibility that other universes could interact with ours is an intriguing one. And while it may sound like the stuff of science fiction, there are actually several scientific theories that suggest such interactions could be happening right under our noses. One such theory involves universe collisions. In this scenario, two bubble universes could collide, causing immense energy release and possibly leaving an imprint on our own universe's cosmic background. This collision could have subtle effects on our reality, altering the fundamental constants or even causing slight irregularities in the fabric of space-time itself. These disruptions might be detectable as ripples in the cosmic microwave background, CMB radiation, hinting at the existence of other universes. But could these interactions be more than just subtle disturbances? Some scientists speculate that these universes might have a more direct effect on our own reality. If universes exist with different physical laws, such as different strengths of gravity or electromagnetic forces, it's possible that their influence could extend into our own universe. For instance, the force of gravity might behave differently in neighboring universes, which could have cascading effects on the behavior of stars, planets, and even the fabric of space-time. In a universe where gravity is weaker or stronger, we might observe entirely different cosmic structures, such as stars that burn out faster or black holes that behave in unexpected ways. But the interactions between universes could go even further. What if other universes with entirely different laws of physics were to bleed into ours? Could these shifts cause anomalies in our understanding of reality, perhaps even affecting the fundamental constants that govern the laws of physics here? Imagine a universe with a slightly altered speed of light, for example. The entire structure of space-time, as we know it, might be altered by the influence of a neighboring universe. These hypothetical interactions might explain some of the most perplexing mysteries in physics, such as dark energy or dark matter. Could the unexplained phenomena we observe in our universe be the result of forces from neighboring bubble universes bleeding into our reality? The idea that the multiverse might not only exist, but be actively interacting with us in ways we can't yet perceive, opens up an entirely new realm of possibilities. The truth is that the multiverse is full of unknowns. While we cannot yet test these theories in a definitive way, the idea that our universe is not alone and that we may share our existence with other bubbles, all interacting in ways we can barely comprehend, is a thrilling prospect. Could the next great discovery in cosmology be the revelation that we are not the only universe in existence? Only time and the advancement of scientific theory will tell. In our own universe, time flows in one direction forward. It's a seemingly simple concept, yet it's one of the most mysterious and profound aspects of our reality. We experience time as an arrow, always moving forward, never backward. But what if time isn't the same in every universe? Could it flow differently in other bubbles, perhaps in a way that defies everything we know about physics? In our universe, time is linked to space in a phenomenon known as space-time, a four-dimensional fabric that bends and warps in response to the presence of mass. According to Einstein's theory of general relativity, massive objects like planets or stars cause this fabric to curve, and this curvature dictates how time flows. The stronger the gravitational pull, the slower time moves. This has been confirmed by experiments in which clocks on Earth and satellites, moving at different speeds, measure time differently. But what if these principles of time and space don't hold in other universes? In alternate bubbles, the very fabric of space-time might behave differently. What if time flows in reverse, or in multiple directions at once? Could a universe exist where time is cyclical, constantly resetting itself in an endless loop? Imagine a universe where past, present and future are not separate events, but exist simultaneously. Time would have no beginning or end. In this kind of reality, causality, where cause and effect follow each other, might not exist as we understand it. Alternatively, what if time operates on a completely different scale in another universe? In some theories, time could flow much faster or slower in certain universes. For instance, a universe where time moves faster could experience billions of years of history in the blink of an eye. Conversely, in a universe where time moves slowly, civilizations could exist for unimaginable spans of time, experiencing lifetimes that extend far beyond our comprehension. Could we in some way detect the presence of such time-bending effects from our own universe? The idea that time might be radically different across universes challenges everything we know about reality. It forces us to reconsider what time even means. Is it an absolute, unchanging force that governs everything? Or is it a malleable concept, susceptible to the specific conditions of each universe? Time may be the most fundamental aspect of our universe, but in the multiverse it might be anything but predictable. Dark matter and dark energy are two of the most elusive and mysterious components of our universe. Together, they make up about 95% of the total mass and energy in the cosmos, yet they remain largely invisible and undetectable by conventional means. But could dark matter and dark energy play a role in the multiverse? Could these invisible forces not only shape our universe but be the key to understanding other realities? Dark matter is a substance that doesn't emit, absorb or reflect light, making it nearly impossible to observe directly. However, its existence is inferred from its gravitational effects on visible matter. It holds galaxies together and prevents them from flying apart due to their rapid rotation. But what if dark matter isn't confined to our universe? Could it spill over from other bubble universes, influencing the structure and behavior of our own cosmos? Similarly, dark energy is thought to be responsible for the accelerated expansion of the universe. But why does it exist and why is it increasing? Some theorists believe that dark energy might not just be a property of our universe, but could be a product of the multiverse itself. In this view, the energy that permeates our space-time might be linked to the vacuum energy of other universes, with their own expansions affecting our own universe's rate of growth. Could dark matter and dark energy be the unseen forces connecting the multiverse? The truth remains unclear, but as our understanding of these mysterious forces deepens, we may find that they're not just cosmic oddities, but vital links to understanding the greater reality. One of the most fascinating and deeply personal aspects of the multiverse theory is the idea that alternate universes might hold different versions of ourselves. Imagine a reality where every decision you've ever made played out differently. In one universe, you chose a different career. In another, you live in a completely different part of the world, and in yet another, you might not exist at all. This idea stems from the many worlds interpretation of quantum mechanics. Every time a decision is made, the universe splits into multiple realities, each one representing a different outcome. In one universe, you might have chosen to go left instead of right, and that single choice could lead to a chain reaction of entirely different events. These alternate realities could create an infinite number of versions of you, each living a unique life. But what would these alternate versions of us be like? In some universes, they might be almost identical to who we are now, with only minor differences. In others, they might be unrecognizable. Imagine a version of you who made every decision you ever hesitated on. What kind of life would they lead? Would they be happier, more successful, or living in regret? The possibilities are as vast as the multiverse itself. Then there's the idea of universes with entirely different physical laws. In these realities, our very existence might take on forms that defy the imagination. If the laws of biology, chemistry, and physics are different, alternate versions of us might not even be human. Could there be universes where life evolved in entirely new ways, leading to beings that share our consciousness but inhabit forms we can't comprehend? What's even more mysterious is the possibility of communication between these versions of ourselves. Some theories suggest that our consciousness might be connected across universes, forming a kind of cosmic web of shared experiences. Have you ever experienced a strange sense of déjà vu, as if you've lived a moment before? Could this be a fleeting glimpse into another version of your life playing out in a parallel reality? And what about dreams? Could they be more than just random firings of the brain? Some scientists have speculated that dreams might be a way for our minds to tune into alternate realities, offering brief glimpses into other lives we might be living. While this idea remains purely speculative, it raises profound questions about the nature of consciousness and our connection to the multiverse. The idea that alternate versions of ourselves exist in other universes forces us to confront profound questions about identity, free will, and the nature of reality. Are we truly unique, or are we just one version of an infinite number of possibilities? While the multiverse theory is far from proven, the notion that other versions of ourselves might be out there, living lives we can only imagine, is both humbling and awe-inspiring. Would we ever want to meet these alternate selves? What would they tell us about our choices, our regrets, and our potential? The multiverse holds many mysteries, but none are as deeply personal as the question of who we might be in worlds we have yet to discover. The idea of bubble universes existing independently within the multiverse might sound like isolated islands adrift in an endless ocean. But what if these bubbles are not as isolated as we imagine? Could they be communicating with one another in ways that are imperceptible to us? This tantalizing possibility suggests that the multiverse might not just be a collection of separate realities, but a vast, interconnected cosmic symphony. To understand this idea, we must delve into the fabric of space-time itself. Theoretical physics suggests that the multiverse could be governed by a larger framework, a meta-universe that encompasses all the individual bubbles. Within this framework, energy or information might flow between universes, much like ripples traveling across the surface of a pond. These ripples could be the result of massive cosmic events, like the birth of a new universe or the collision of two existing ones, sending out signals that resonate across the multiverse. One possible mechanism for this communication is quantum entanglement on a multiversal scale. In our universe, entangled particles remain mysteriously connected regardless of the distance between them, influencing each other instantly. If this phenomenon extends beyond our universe, could particles in one bubble be entangled with particles in another? This would mean that universes are not entirely separate, but are subtly interconnected through the enigmatic laws of quantum mechanics. Another intriguing idea comes from the concept of brain cosmology, which posits that our universe is a three-dimensional membrane, or brain, floating in a higher dimensional space. If other brains exist in this higher dimensional space, they might occasionally come into contact or interact. Such interactions could create shockwaves that ripple through the multiverse, leaving detectable imprints in our universe, like unusual patterns in the cosmic microwave background radiation. Some scientists even speculate that black holes could serve as gateways for information exchange between universes. When matter falls into a black hole, it is compressed to an unimaginable degree, potentially creating a singularity that pinches space-time. If this singularity is connected to another universe, the information absorbed by the black hole might be transmitted to the other side. Could this be why black holes seem to defy our understanding of physics, acting as cosmic hubs in an inter-universal network? The possibility of communication between universes raises profound philosophical questions. If universes can exchange information, what kind of messages might they send? Could a more advanced universe be attempting to guide or influence us, subtly shaping the development of life and intelligence in our cosmos? Or are these inter-universal connections purely mechanical, driven by the underlying physics of the multiverse with no intent or purpose? While we have no concrete evidence for communication between universes, the very notion challenges our understanding of isolation and connection. It forces us to reconsider the boundaries of existence and opens the door to a vision of the cosmos that is far richer and more dynamic than we ever imagined. If the multiverse is a symphony, then perhaps we are just beginning to hear its faintest notes, a melody that hints at a much grander composition. Time, as we understand it, is one of the most fundamental aspects of existence. It flows relentlessly forward, shaping every moment of our lives and the evolution of the cosmos. But what if time itself is not a universal constant? In the context of the multiverse, the nature of time becomes far more complex and mysterious. Could each bubble universe have its own unique timeline with its own rules and flow of time? To grasp this concept, we must first understand that time is not an absolute quantity. In our universe, time is deeply intertwined with space, forming the fabric of space-time. Einstein's theory of relativity revealed that time can stretch and compress, depending on the strength of gravity and the speed at which an object is moving. In the multiverse, where each bubble could have different physical laws, the behavior of time might vary drastically from one universe to another. Imagine a universe where time flows backward, with effects preceding causes. In such a reality, beings might perceive their existence in reverse, starting at the end of their lives and moving toward their beginning. To us, this would seem incomprehensible. But for the inhabitants of that universe, it would be the natural order of things. Now imagine another bubble where time is not linear at all, but cyclical, repeating endlessly like a loop. What would existence look like in a universe where history repeats itself forever? Even more perplexing is the idea that some universes might experience time in ways we cannot even conceptualize. What if time in another bubble flows in multiple directions simultaneously, or exists as a static dimension where past, present, and future coexist? In such a universe, the inhabitants might perceive all moments of their existence at once, experiencing reality as a timeless state of being. The concept of time in the multiverse also raises questions about the origin and fate of universes. In our universe, time began with the Big Bang and will continue until its eventual end, whether through heat, death, a big crunch, or some other cosmic finale. But what if time in other universes follows a completely different trajectory? Some universes might have no beginning or end, existing eternally in a steady state. Others might blink into and out of existence in an instant, like bubbles popping on the surface of a boiling pot. The mysterious nature of time in the multiverse also has profound implications for our understanding of causality and free will. If time behaves differently in other universes, could it be possible to travel between them and experience alternate timelines? Could we see alternate versions of our own history where key events played out differently? And if so, what would this mean for our sense of agency and the choices we make? While we may never fully understand the nature of time in the multiverse, the very act of pondering these questions expands our horizons and deepens our appreciation for the mysteries of existence. Time, in all its enigmatic glory, might be the thread that weaves the multiverse together, connecting countless realities in a tapestry of infinite possibilities. What secrets does the multiverse hold about the nature of time? And how might those secrets reshape our understanding of reality itself? The quest to understand the multiverse is just beginning. Could there really be other universes out there, each with its own laws, its own form of life, and its own mysteries? If you've enjoyed this journey into the unknown, be sure to like, share, and subscribe to Cosmic Buzzin' for more mind-bending content about the wonders of the universe. We've only scratched the surface. There's so much more to explore, and you won't want to miss a single discovery.